Hello everybody, so in this video we are going to be covering the oxidation reduction process, the oxidation and reduction differences, the oxidation numbers in a chemical reaction, the oxidation number and the periodic table, and a quiz and some working examples. So let's get started. Alright, now let's go over the oxidation reduction reaction. So the oxidation reduction reaction is a type of chemical reaction that involves a transfer of electrons between two species. An oxidation reduction reaction is any chemical reaction in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron. So a substance is oxidized if it loses an electron or becomes more positive because an electron is negative, and a substance is reduced if it gains more electrons or becomes more negative. This means that you cannot have an oxidation reaction without also having a reduction reaction. Now this picture on the right explains the oxidation reduction reaction by showing the transfer of electrons. So you can see that hydrogen over here is losing an electron as oxygen takes it. So hydrogen is being oxidized and oxygen is being reduced. So now let's go over this picture on the left. So this picture explains the complete process of oxidation and reduction. So if you can see, in this picture, they use the terms reducing agent and oxidizing agent. And this might be a little bit confusing at first because a species that gains electrons is called an oxidizing agent and a species that loses electrons is called a reducing agent. And it's kind of opposite to the fact that oxidation is the loss of electrons and reduction is the gain of electrons. So here, the oxidizing agent is compound B, and it wants to take two electrons from compound A, which is the reducing agent. So compound B oxidizes compound A and takes its electrons. So we can see compound A is now oxidized. It does not have those two electrons. And if you look at compound B, it has now taken those two electrons from compound A. And as I said before, whenever there's an oxidation reaction, there also has to be a reduction reaction. And the reducing agent, compound A, reduces compound B by helping it gain electrons. So one example of the oxidation reduction reaction is that we need to breathe oxygen in order to live, and that is because oxygen is a key element in breaking down food into energy in our bodies. So remember that oxygen has two missing electrons, and they do whatever it takes to steal an electron. So this process depicts the food cycle, which includes photosynthesis, cellular respiration, and the food breakdown. So carbohydrates or glucose, in other words food, is produced when plants intake carbon dioxide, water, and sunlight. They convert that into food. And when a person consumes that food, they break it down with the help of oxygen and converts it back into carbon dioxide, water, and energy. And during this process, carbon is oxidized to produce carbon dioxide, and oxygen is reduced to produce water. Oxygen gains electrons in both cases. You can also think of a similar oxidation process that rots an apple. So essentially, when you cut open an apple, an enzyme in that fruit reacts with oxygen to turn polyphenols into melanin. So now let's look at this picture on the right. So this is a picture of rusted metal, and rust is the common name of a chemical called iron oxide. So the rust forms when iron is exposed to moist air. So the oxygen and the water in the air react with the metal to form the oxide. It's typically in a reddish-brown color. Now let's look at the chemical reaction on the left. So this chemical reaction is the opposite of rusting and can occur at 700 degrees Celsius. So we have iron oxide, rusted metal, reacting with carbon monoxide to leave with iron and carbon dioxide. So let's translate the above chemical equation into an ionic bond model. So let's first start with this iron oxide part. So we know that oxygen is in the sixth group of the periodic table, and each atom needs 2 electrons to complete the octet. So it has a negative or 2 minus charge. And in the iron oxide, there are three oxygen atoms, and hence would need 6 electrons. Therefore, iron will have to give it 6 electrons. And there are 2 iron atoms, so each iron atom is giving 3 electrons, and hence left with the 3 plus charge. So similarly with the carbon monoxide, so oxygen is gaining 2 electrons, and so carbon must be losing 2 electrons as well. Therefore, carbon is 2 plus charge and oxygen is 2 minus charge. So now let's review the product side now. So here, the iron is alone, which means it has gained 6 electrons. It no longer has to give electrons to the oxygen. And in the carbon dioxide, there are 2 oxygen atoms. There are 2 oxygen atoms instead of 1. So carbon now is losing 4 electrons instead of 2. So iron is gaining electrons or getting reduced. Carbon is losing electrons or getting oxidized. So the oxygen here is actually neutral, and that is because it is gaining 2 electrons both on the reactant and the product side. Alright, now let's go over what we've covered so far. So, oxidation is the process of losing electrons. Reduction is the process of gaining electrons. In oxidation, the species is oxidized. In reduction, the species is reduced. In oxidation, the species becomes more positive. In reduction, the species becomes more negative. Oxidation affects the reducing agent. Reduction affects the oxidation agent. So now let's go over the examples of oxidation and reduction in the chemical equation above. So the example of oxidation in this chemical equation is the carbon. So before the chemical reaction, the carbon only had to give 2 electrons to the oxygen. But after the chemical reaction, the carbon now has to give 4 electrons to the oxygen. So an example of reduction is the iron. So each atom before the chemical reaction had to give 3 electrons to the oxygen. And now after the chemical reaction, each atom of iron has gained 3 electrons as it no longer has to give those electrons to the oxygen. So some of the ways to remember this is Leo the lion says Jer, or the loss of electrons is oxidation and the gain of electrons is reduction. So another way to remember is oil ridge. Oxidation is loss and reduction is gain. So the oxidation number of an atom is the charge that an atom would have if that compound was composed of ions. So the oxidation number of an atom in a neutral substance is 0, and that contains atoms of only one element. Thus, the atoms in oxygen ozone, phosphorus, and octosulfur, and aluminum metal all have the oxidation number of 0. So note that the table here is the periodic table, and the charge listed reflects the number of electrons. The number of electrons are particular elements in its respective group like to lose or gain to complete their octet, or 8 electrons in their outermost shell. For example, oxygen and sulfur are both in the 6th group, which means they need 2 more electrons to complete their 8 electrons. And sodium, it has 1 extra electron that it would like to lose. Another thing to note is that transition metals have multiple oxidation numbers because they are d orbital elements, and there is very little energy level difference coming from 3d orbitals and 4s. So therefore, their energy levels are hybridized and start to offer a different number of valence electrons. Therefore, many metals offer oxidation numbers of 1, 2, 3, and 4. Some even offer 5 and 6. Now let's go over some oxidation reduction exercises. So question 1. What is the loss of electrons called? Oxidation. Question 2. What is the gain of electrons called? Reduction. Question 3. A species that gains electrons is called an oxidizing agent. True or false? True. Question 4. A key function of oxygen in the human body is to break down food molecules. True or false? True. Question 5. What is photosynthesis? Photosynthesis is a process converting carbon dioxide, water, and sun energy into carbohydrates. Question 6. Why does iron rust? Rust forms when iron is exposed to moist air. The oxygen and water in the air react with the metal to form the oxide. So iron and oxygen form to make rust. Question 7. What is the oxidation number of noble gases, the 8th group in the periodic table? 0, because they have all 8 electrons. Question 8. What is the oxidation number of hydrogen, or the 1st group? +1, because it has 1 electron to share or lose. So now let's go over our first working example. First working example. Please find the oxidation number of the listed element in the corresponding compound. So the first element is carbon. So we need to find the oxidation number of carbon in the compound carbon dioxide. So we know that oxygen is in the 6th group. So that means that it only needs 2 more electrons in order to get its full 8 electrons. So every oxygen atom needs 2 electrons, and we have 2 of them. So this needs 4 electrons. And this compound is stable, which means that carbon needs to give 4 electrons. So the oxidation number of carbon in carbon dioxide would be 4+. Now let's go over our second example. So our second example is the element sulfur and the compound sulfuric acid. So let's first start off with this oxygen bit. So we know that every atom of oxygen needs 2 more electrons, and we have 4 atoms of oxygen, which means that this needs 8. But we also have hydrogen, and hydrogen is in the first group, which means that every atom of hydrogen has one electron to either lose or share, and we have two hydrogen atoms, which means that this can give 2 electrons. But we still have 6 electrons more to give, which means that sulfur's oxidation number would be 6 plus. Now let's move on to our third example. So this is the element hydrogen in the compound hydrochloric acid. So the hydrochloric acid is essentially just made up of hydrogen and chlorine. And if we find chlorine on the periodic table, we can see that it is in the 7th group, which means that it needs one more electron. So hydrogen has to give that one more electron, which means the oxidation number for hydrogen is 1 plus. Now let's do this fourth example. So this fourth example is the element chromium in a dichromate ion. So this is an anion, so they have already given us 2 electrons. So a dichromate ion is made up of chromium and oxygen, and chromium is a transition metal. And as I said before, transition metals can have any oxidation number. So now let's get back to solving this. And so as I said before, every oxygen atom needs 2 electrons, and there are 7 of these, so this needs 14. But this is an anion, and they have already given us 2 electrons. So the chromium only has to give oxygen 12 instead of 14. But there are two chromium atoms, which means that each chromium atom has to give 6 electrons. So the oxidation number of chromium would be 6. Alright, now let's do our next example. So this is the element carbon in the compound difluoromethane. And difluoromethane is made up of carbon, hydrogen, and fluorine. So let's first find fluorine. So fluorine is in the 7th group, which means that every fluorine atom needs 1 electron. And there are 2 fluorine atoms, which means this would need 2 electrons. So we already know that every hydrogen atom has 1 electron to either lose or gain. And there are also 2 hydrogen atoms here. So we can put 2 plus. So assuming that this compound is stable, that would just mean that the oxidation number for carbon would just be 0. Now let's do our next example. So this is the element iron in the compound iron oxide. And iron oxide is made up of iron and oxygen. So iron is a transition metal, and as I said before, transition metals can have any oxidation number. So we already know that oxygen, for every oxygen atom, we need to give 2 electrons, and there are 3 oxygen atoms, so you would need to give 6 electrons. So that would mean that iron would have to give those 6 electrons. And there are two iron atoms, which means that they would have to split it, and the oxidation number would be 3. Now let's do our last example. So this is the element sulfur in the compound sulfur dioxide. So sulfur dioxide is made up of sulfur and oxygen. So we already know that for every oxygen atom, it needs 2 electrons. And there are 2 oxygen atoms in this, so it would need 4 electrons. So sulfur has to give it 4 electrons. Therefore, sulfur's oxidation number would be 4.
Thanks for watching. If you liked this video, remember to drop a like and subscribe. Hope to see you in my next video. Bye!